Hey everyone, I hope you all are doing really good. So I am here today with another amazing data engineering project for all of you. So if you are an aspiring data professional, you are definitely going to learn a lot of things from this video. So make sure to watch it till the very end. So what we are going to do in this video, we will create a data pipeline using Astronomer, that means managed Airflow. And in this data pipeline, we will try to read the JSON files from the Google storage bucket, then load them in the overwrite manner in the BigQuery table, and then trigger the PySpark job on GCP Dataproc serverless. And this PySpark job will process the data from the BigQuery tables, perform certain transformations, join operations, and then write it into another BigQuery table in the append manner. So this is what we will be doing in this pipeline, and everything will be orchestrated and managed in the Airflow itself. And to complete this project, you need two things: free tier account of the Astronomer and the free tier account of GCP. And apart from that, whatever code and data set I am going to use in this project, for that one I will be providing the link in the description. You can access it. So let's look at how you can set up the free trial account on the Astronomer. It's very easy, just few clicks you need. I have given the link in the description. Just click on that and you will be landed on this particular web page, and you can see get started for free. Just click on it, provide simple details, and you will be done with your 14-day free trial account. So link has been given in the description. And recently Airflow 3.0 was also launched. So I will be talking about few interesting new upgrades you will see in the Astronomer UI. So after creating your free trial account, you will see this kind of home page where you would have created a workspace named with anything, and then inside your workspace you can create multiple deployments. And deployment is nothing but setting up your Airflow cluster, maybe on different cloud platforms. So currently I have one deployment named as Astro Project Airflow, and that is on the GCP itself. And on this deployment I can see Open Airflow, so that I can access the Airflow UI, and this is how it will look like. And as I said, after Apache Airflow 3.0, a lot of things have been changed, and one interesting new upgrade which I like the most, the DAG versioning. Apart from that, there are cool updates on the UI as well, much more on the observability side and the different execution histories, everything, logging part. A lot of changes have been done, so this is really cool. And you can see the DAGs are present here. So I will show you the step-by-step process how I have done it, and you can create your deployment quickly. Here you just need to provide certain details, and you need to choose the cloud platform where you want to host it. So example, you can create one Airflow environment for the dev, one Airflow environment for the staging, and one Airflow environment for the production. So 3 different deployments you can create. And the best thing is you can set up Astro project in your local machine very quickly by following few simple commands. So here is the detailed page of it, you can see, and this is how even I have set up the project in my local. So we will be using that one, and whatever changes we will be making in our local code base, we will be able to push these changes into the deployment which we have created here, like all the new DAGs which we are creating and the different changes we are making in our DAGs. We will be able to deploy it. But first of all, you need to follow this page and the commands. You will first install the Astro in your local system, and then first of all you need to also create the deployment on the Astro environment, and then simple follow these steps. Just create a project folder on your desktop, and after that run this command astro dev init. As soon as you do that, this kind of project structure will get created in your local system itself. Because first of all, whatever changes we are making, we would like to test it in our local environment as well. As soon as you do the astro init, this kind of structure will get created, and then you can even run the Airflow in your local and test your pipeline, and then you can deploy it in the Astro environment. And now let's talk about the GCP, what kind of setup you need there, and then we will come to the development part of it. So in the GCP, first of all, you definitely need a free tier environment, so make sure to set it up on your own. Very easy to do that. Multiple pages and links are given on the internet to do that. So here you actually need 2 buckets. One bucket named as this one, Astro Airflow project. I have created it. Creating the bucket very simple, and inside that one I have created 2 folders. One folder named as the datasets, and one folder named as the scripts. So in the datasets folder, I have two more folders, orders and the products. So this folder will have the orders.json file, and then we have the products folder which will have the products.json file, and this is what we will try to read in our pipeline. So this is about the data set. I will show you how our data looks like and will provide you the same. So for the bucket level, this is one bucket you need, and apart from that you need one more bucket, because that would be needed for the BigQuery in order to do any intermediate write operations before loading it from somewhere to the BigQuery. So I have created one more bucket named as BQTempGDS. So do that, and inside that one create one folder named as BQTemp, right? So just create it, set it up. That is what you need. And apart from that, you also need to create the data set in the BigQuery and 3 table structure. And how to create it? Basically the create table command, I will provide it, and you can simply run those create table commands and all your 3 tables will get created, because our raw JSON data will be written into the orders and products table. Then our PySpark job will read the data from these 2 BigQuery tables, process it and write it into the another table. So in the BigQuery, right, so you can see I have created one data set named as the retail data and 3 tables. One is the orders table. If I show you the schema of it, so this is how it looks like. And similarly the products table, this is how the schema of it looks like. And currently if you click on the preview, there is no data because these tables are empty. And this will be our transformed table, like the transformed data after the join and transformation we will be having, it will be written here. So ultimately our PySpark job will read these 2 BigQuery tables, orders and the products, and performing transformation on top of it, joining it and writing in the append manner in the enriched orders table. So this is what will be done. So make sure you create the data set, and inside that one you can create the tables. I will be providing the create table command for these 3 tables. Okay. So this is what you need on the BigQuery, and this is what you need on the bucket side. Let me quickly show you how the data looks like. So if I open this orders JSON data, so you can see order ID, product ID, user ID, quantity, order date. So every single line is one JSON record, and this is how it is supposed to be read and written into the BigQuery table. Similarly, if you look at the products.json, this is how it looks like. The product ID, name, category, price, in stock. So for this pipeline itself, we are going to work in the dummy data format, but at the end of the project, I will give you one exercise to fine tune this project a bit more. So make sure to watch it till the very end to get that exercise. So now let's look at our Airflow DAG, that what kind of tasks and what kind of operators we are going to use there, and what else you need just to make this project working, because at the end our Airflow is going to connect with the GCP. So how to set up that connection and what operators are supposed to be used, and then after making the changes in the local project, how I can deploy this thing into the Astro environment, which is somewhere else. So how to authenticate that thing, I will be showing you step by step. Okay. So let me open it. So whenever you are writing a Airflow DAG, you need to put it inside this one so that it can be deployed whenever you are deploying the entire project or the DAGs only. So here, this is the DAG I have created, and let me quickly show you how it is going to be step by step. So here I am using the GCP provided operators for the Airflow. One is the GCS to BigQuery operator, because our JSON data is located in the Google Cloud Storage. So from there, I need to write the data in the BigQuery. So I am going to use this operator, and another operator, dataproc create batch operator, right? So dataproc create batch operator means to submit our PySpark job in the dataproc server list. I need to use this one. So first I'm creating the DAG object. This is the DAG ID and the start date. Schedule is none here, means there is no schedule time of it. As soon as we deploy, we can manually run it, but you can schedule it. Catch up equals to false, just to avoid any backfill executions, and these are the tags simply. And then after that, we are simply writing a functions where we are defining these individual tasks. And then after that, we will put them in a sequence to get executed. So here you can see first variable, we are defining the project ID, which is nothing but the GCP project ID. So here if you can see, this project ID is actually coming from the Airflow variable. We are not hard coding it here, and with the help of Jinja notations, we are trying to access this one variable we have defined. But where to define and how to define, let me quickly show you. So for that one, you need to come to your Airflow deployment, and from there you can access the Airflow UI. And as soon as you come here, you can see this option admin, and just click on it, and here is the variables part. So if you go to the variables, you can see I have created, and this is simply my GCP project ID. So you can simply click on this one, and let's say GCP project ID new, and whatever is your GCP project ID. For my case, if you come to here, I am inside this GCP, and this is the project, and this is the simple ID, right? So this is what you can get and you can create here. So once this is done, we are good with this part, and we will be able to access it. So let me come back here, and this is how, with the help of Jinja notations, we are trying to access this value. Then this is the BigQuery data set, and this is the bucket, means our source bucket where the folders and the data sets are placed. And then this is the temporary bucket we will be using for the BigQuery. And this is the operator we are using. First, we will be loading the products data into the product BigQuery table, then orders JSON data into the orders BigQuery table. So GCS to BigQuery operator, this is the task ID. And this is the interesting part. As I said, that your Airflow job is actually trying to work with some kind of GCP account, right? So how your Airflow operators task, whatever you are writing, how they will be able to figure out that which GCP account we need to connect with and perform certain operations, right? So in order to do that, we are using one attribute GCP connection ID, and we are trying to use this connection. So how to create this connection and where to define it, let me quickly show you, because that is important. So again, coming back to the deployment we have here, if you see this thing, there is one tab environment. Just come here, and you can see I have created one connection named as the GCP con, and this is exactly what I am using here. But how to do that, how to create it, that is the important question, and specifically for GCP. Similarly, let's say you are trying to connect with a Snowflake or any other thing, similarly you need to create those connections as well. Okay, so click on connection, and here you can see multiple entities which you can connect with and work with. So here you simply need to type this Google Cloud. So here you can see this Google Cloud platform key file. Just click on it, and now here you need to provide the GCP connection ID. So for an example, GCP connection new, this is the connection name I have given. And you can turn on this option. You can see, right, automatically link to all deployments. Let's say you have the deployment for the dev, stage and prod, means three different Airflow environments, and you want this connection to get added with all those three. So you can simply enable this option and it will get added. And now what you need to put here, key file JSON, this is important question. So this is actually coming from the IAM or the service account you have in the GCP, because in GCP we have this thing, if you type the IAM, so identity and access management, so everything works with the service account, and service account basically have the different roles and permissions to work with different services. So you can open this one, and here you can see this is the principal or the service account, and it has all these kind of permissions to do. So here you can get started with simple thing, means you need to make sure whatever service account you have, it can fire some you can say job on the Dataproc, it can read from the you can say Google Cloud storage. So whatever BigQuery and the GCP storage and the Dataproc related roles are there, you can simply add in this principle. You can simply go to edit, and here you will see this option add role. You can find the relevant role and add. Okay, so let me come here, and how you can download that file, this is the question. So you can come to service account. So as I said, this is the service account I will be using. You can see these three dots. You can click on this manage keys. So click on it, and after clicking on the manage keys, it will ask you to create a key, right? Add key option. So here you can see create new key and key type JSON. Once you click on create, it will basically create all the access related content like the private key, public key, and all other authentication related content, and will put it in a JSON file, and it will be available in your download section. Then after that, what you need to do, you need to open that JSON file and copy the content of that JSON file, and you can simply put that content here in this one. Just exact copy paste, that's the only thing you need to do, and you can simply click on create connection, and your GCP connection is created now. Then coming back to the rest of the part. So here we are mentioning the bucket, in which bucket the data set are present, then source object, which object we want to read and write in the BigQuery. So you can see we are mentioning that complete path. So you can see here, if we come to our bucket, this was Astro Airflow project in the data set and the products, right? So this path, data set products and the products.json, right? So this is what is mentioned here, and we are mentioning in which BigQuery table we want to write. So project ID, data set, and the products BigQuery table name. Source format, write disposition means we want to do every time this jobs runs, every time it should do the overwrite operation. So that's why write truncate. Auto detect means detect the schema and the data type automatically, and the location means the location of our BigQuery data set, in which region it is located. So the data set which I created in the BigQuery, it is actually in the US Central 1 region. So that's what I have provided. So same thing you are doing for the orders table as well. You can provide the similar details. Now coming to the main part, which is running the PySpark job on the Dataproc serverless. Okay, so for this one we have this operator, Dataproc create batch operator. So watch it carefully that what all things I am going to provide here in the options. So first is task ID, then GCP connection ID, GCP project ID we are passing here, and the reason means in which reason we want to spin up the PySpark job on the Dataproc serverless. So that reason we are mentioning, it could be US East 1 or something as well. And then we are also mentioning this payload, the batch payload, which basically have all the details like which PySpark job, any supported jar files, any Py files, which Dataproc Debian image version needs to be used, plus all the network subnetwork related information, right? So here you can see we will be running the PySpark batch job. So main Python file URI, right? So this attribute basically represents the location of our PySpark job, and this is what I'm going to talk about next. So here, if you look at this part, we also have one more folder named as script, and inside that one I have already uploaded this transform join ecommerce.py. So this is our PySpark job, how it works. Let's quickly look into that one. So let me open it. So this is our PySpark job. Let me quickly open it and show you that how it looks like. So yeah, here we have our main function, and this PySpark job actually expecting 3 input arguments. One is the project ID, one is the BigQuery dataset name, and then the bucket for the BigQuery temp operations. So we are expecting these 3 input arguments, which we are passing here as well. If you can see, as soon as we mention the file path, we are mentioning these 3 arguments like the project, dataset, and the temp one. And after doing so, what we are doing, we are creating our Spark session, and after creating the Spark session, we are first trying to read our products table, means creating the data frame on top of it. then performing certain transformations on top of it, like deriving a new column named as the price tier. And then we are trying to read the orders data frame from the orders BigQuery table. And after doing so, we are just selecting a few columns and converting the date, which is in the timestamp manner, into the actual date format of the orders data frame. Then we are joining the transformed orders data frame with the transformed products data frame on the product ID column, and the join type is inner. And after performing the join operation, we are selecting the specific columns which we need in our output. And now after that, we are simply trying to write this particular data frame joined df into the BigQuery into the some target table, which is that enriched table I showed you, and temporary GCS bucket that would be needed. That's why we are passing it from the input arguments, and mode will be append, means data will be written into that final transform table in the append manner. So this is about our PySpark job, and as you can see, I have already uploaded it here. Again, coming back to our Airflow job. So here there is no jar file needed for it. So that's what we are not passing, because Dataproc is already able to connect with the BigQuery. They are in the same you can say account and the project itself. So Dataproc does not need Spark BigQuery connector. It's already there. We are not passing it. Then this is the runtime config, means which Dataproc Debian image we want to use. So 2.2 is the latest series of that. That's what we are using. And then this is the environment config we need to provide related to this thing, like which service account we want to use, and the network URI and the sub network URI, right? So this is what my basically GCP project ID. Rest all are the keywords like projects, global, networks. And whenever you set up a GCP free tier account, one VPC with the name as default gets created. So same thing I'm using here as well. All right. So this is what you can see, and you can pass as it is. And then you can see we are setting up the task dependency. So these two tasks are not dependent on each other. They should run in parallel. So we are putting it in this square bracket, and then we are just running our Dataproc job. So this is what we have in our Airflow job we have created. Now the time is for the deployment. So let me quickly show you that how we can do that. So as I said, this is your local project now, and if you want to deploy all these things, so first thing you need to make sure that in your Airflow job, right, what you are doing, you are trying to access some GCP Airflow operator related things, means you need to add that package. So for that one, you can see your requirements.txt, and inside that one you need to add this Python package, Apache Airflow Providers Google, because whatever you are writing here, Airflow Providers, this is coming from a package. So you need to mention it here. So now since you have added something into the requirements.txt, so how this entire deployment process works. So as soon as you have, maybe if you are only making changes in the DAGs, then you do not need to create the entire image of your project again and deploy it. But by any chance you are making some other changes, specifically adding few more packages or something, so it is quite obvious that your project build should get executed first, because here the whole deployment is based on the Docker image. You can see a Docker file as well, which is having this thing. And apart from that, during the build process, this requirement.txt also gets used. So if you have added a new project, you need to make sure that you are first deploying your project. Deploying a project means the entire image will get created first, that will get deployed, and along with that one, your DAGs will also get deployed. And now after that, let's say you are only making changes in the DAG and something, you can only deploy your DAGs. I will show you. Okay. So here, if I want to do that deployment, first my terminal should get connected with the Astro environment I have. So for that one, you simply need to run this command astro login. And once you do this, hit enter, it will redirect you to a web page where it will ask you to authenticate your Astro account. Whatever email ID password you had for your free trial Astro account, you need to type it so that your terminal is getting connected with the Astro account. So that is the thing you need to do. And after doing that part, right, what you need to do here, Astro deploy, right? Once you click on the Astro deploy, like once you hit the enter and run this command, so it will start building the entire Docker image with all the requirement.txt thing, whatever you have mentioned, whatever DAG you have, right? It will create it, it will deploy it as well. So if I show you, I did that deployment. If you come to deployments, so if I open it, I will be able to see it that this is the deployment I did. And here you can see the type was image because entire image got built again. But after that, I am only deploying the DAGs. I do not need to build the entire image again. So once you want to deploy your complete project for the very first time, make sure to run the Astro deploy so that the entire project with all the necessary dependencies is getting deployed. Now let's say I have done it, and once you will do, your Airflow DAG will be reflecting here. If there is no error as such, if there is any error, you will be able to see on the Airflow UI itself that some import error or something like that. And so now if I open this DAG, so you can see this is how it looks like, these two parallel tasks and then running this Dataproc serverless job. And this is what I like more about this new things which have been introduced after the Airflow 3.0. And one important thing, the intuitive UI. A lot of things are pre-visible here. You can check your code here that what is the Airflow code currently. And one of the important feature which I am really liking, that is the DAG versioning. Means whatever changes you are doing in your DAG, n number of times, every time you are deploying it, a new version is getting created. So you are getting a backward forward compatibility time. You can switch to any version, any specific point of time, and you can trigger that DAG. So that's the beautiful thing. And here you can see all the run history, and apart from that, you can open it and you can see the status of each task. And again, if I go back to the DAG and go to the runs, and let's say any of the execution was failed, so you can look into it. You can see the logs very easily that what kind of issue was there. So all these things are very intuitive, but the DAG versioning is something which stole the show in the Airflow 3.0. So I'm really liking it because that was much needed. So let's add some bash operator maybe at the end of this one and try to update that DAG and redeploy it. So let me add this thing here. We will be using this bash operator, and then here after this one, run dataproc, we will have this dummy message, and here we will be having our bash operator which we are trying to use. Okay, so this is here, and let's remove it. This is not needed. Dummy message operator, dummy message operator, and here job done, as simple. And let's try to add it after this one. Cool. So here we have made some changes in the existing DAG. So idea is, we are not going to deploy this entire project again. We are only interested in the deployment of the DAGs. First of all, as I mentioned, that we will be authenticating our terminal or the local system to get connected with the Astronomer environment. So for that, we executed Astro login, and assumption is we are now connected with that. So in order to just deploy your DAG only, what you need to do, you need to run Astro deploy -- DAGs. And since we are connected with our Astro environment, it is able to list down all the deployments which are created, means different Airflow environments, and it is asking us in which Airflow environment you want to deploy your updated DAG. So here I am selecting one because I only have one deployment there. So just use it, hit enter, and here it will be deploying that one. So in case there is no error or something, I mean, we should be able to see the changes in just couple of minutes. And here you can see this is the existing code, this is the existing DAG. So ideally after these changes we have deployed, our DAG should get updated with one more operator. So here this is what we can see. New changes have already come up here. I have verified it from the changes, right? We added one more operator at the end and we can see even in our graph. Okay, so cool, we are good here. Let's execute this one and try to see whether it is working or not. So here let's manually trigger this thing, and as soon as we do that, we will be able to see the new run which has started. So you can see it is in the running state. And now as soon as I open the new run execution, here these are the two tasks which are in the queue. So first this will get executed and we will verify it. These tables should be there. So now they are in the running state, and as soon as they are succeeded, we should be able to see some data in those orders and product BigQuery table. So you can see this is succeeded, this is also succeeded, and this job has triggered. So let me quickly come here and refresh the BigQuery UI and show you this part. So here if I come and retail data, and if I open orders table, so here we can see the data is in the preview. And now if I quickly come to the data proc, because the data proc serverless job has kicked in, and if I come to the batches under the serverless, so here you can see one job has come into the picture, ecom transform, and in the pending status. So now let it complete, and then we will be able to see our final table populated as well. Cool, so here it is succeeded, and it should be done here as well in just a couple of seconds with the status change. Let me refresh it probably once. Cool, this is succeeded, this is also succeeded, and you can see the logs as well for all the tasks, and here you can see the job done thing which we had. So yeah, everything is succeeded, and we can verify. We can come to our enriched order tables, and let's come here and see the preview. Perfect. So you have your end-to-end running data pipeline which has populated your table. Now the exercise for you, we have created this pipeline a bit static. I mean, it is trying to read that fixed file which we have placed here, like the orders.json, products.json, right? And same thing we have mentioned in our code as well, right? The DAG basically. So we have mentioned read this specific file. So now the exercise for all of you, fine tune this DAG so that this can be parameterized as well, right? So example, your order.json and the product.json will come with this kind of format. Let's say products and yyyy-mm-dd.json. So every day basically you will be getting some files for the products and some for the orders one, right? So now let's say you are getting it in this way. So ideally your DAG should be expecting some date parameter, right? So date parameter, like if user is explicitly passing some date value, so the files for that specific day should be read. If that is not the case, user is not passing anything, then the files for the current date should be read from the bucket. So that is the exercise for you to do it. And as I said, I will provide all this code base data set I have used. Link is given in the description. You can access it and make sure to just play around it and set up your free trial account on the Astronomer. Again, I have given link for that in the description. So that is pretty much I had for all of you in this data engineering video. I hope you liked it. You will be able to build this pipeline for sure. It's very interesting, and let me know in the comment section if you have another project idea which you want me to develop with another tech stack, whatever it is. Let me know in the comment section. I will be happy to create a tutorial for the same. So if you find it informative, make sure to give a like in the big number, and if you're new to the channel, then make sure to hit the subscribe button and press the notification icon. I will see you guys really soon with another amazing video. Till then, just keep exploring data.